Hey everybody, how you doing? Today we are adding and subtracting rational expressions. We first did some simplifying and then we did some multiplying and dividing. So now we're going to add and subtract. Um, Now the one thing you got to remember about your days from adding fractions in elementary school is that you had to have a common denominator. And when you look at number one, we do have a common denominator. So we can go ahead and add them together, and you'd get 5x plus 10. This is a variable, that's a number, so you can't combine them together, all over x squared minus 4. But now we got to simplify it, of course. 5 times x plus 10, you could factor out a 5, and that would become x plus 2. The denominator is a difference of two squares, x plus 2, x minus 2, and then what do you know? Stuff cancels out. So we cancel out the x plus 2's, and you end up with 5 over x minus 2. That's when you have common denominators, which is, of course, not what usually happens. Let's take a look at number 2. In number 2, you look at the denominators, and they look kind of similar, but they don't match. They are not common denominators. So we first are going to want to simplify them both and kind of see what's really in both denominators. This first one, let's see if I factor that. That factors into x plus 3, x minus 2. And the second one, let's see, I think that looks like x minus 2, x minus 3, multiplies to positive 6, yet adds up to negative 5, those two numbers. So when I compare these two denominators, they both have an x minus 2. Now this one has an x plus 3, but this one does not have an x plus 3. So I'm going to multiply the numerator and denominator by x plus 3. At the same time, this one has an x minus 3 that this one does not have. So I'm going to multiply this numerator and denominator by x minus 3. And when I work all this out, my denominator, I'm just going to leave it just like this, a nice factored form denominator. So x minus 3, x plus 3, x minus 2. Order does not matter because when you're multiplying three numbers together, as long as they're just being multiplied, you're okay. So that it doesn't matter what comes first, what comes second, and what comes third. On the numerator, x times x minus 3 is x squared minus 3x plus this stuff. This is like having x minus 1 times x plus 3. You got to completely FOIL it together. X squared plus 3x minus 1x makes a plus 2x, and then negative 1 times 3 is minus 3. Ooh, now I have like terms that could be added together. I'm going to do a little side work here now to deal with this numerator. X squared plus x squared is 2x. 2x squared, that is. Negative 3x plus x is negative x. And then I have this minus 3. And now this, oops, so once again, x squared plus x squared is 2x squared. Negative 3x plus 2x is negative x. And then this negative 3 is kind of a lone wolf. Then I bet this is factorable. 2x and an x would be the only way to go. And let's see, if I put the 3 here, the 1 here, and went minus 3 and plus 1, negative 3x, positive 2x. Hey, checks out. So this numerator, in 2 steps of work, I add all the like terms, it becomes this. I factor it, it becomes this. So I end up with 2x minus 3 times x plus 1 all over x minus 3, x plus 3, and x minus 2. And at this point, you would expect something on the numerator and denominator to cancel out, but nothing is canceling out on the numerator and denominator. So I'm just going to leave my answer just like this, but that does make me feel like I made a mistake somewhere, so I'm just going to do a quick check on this. Let's see, this factored this way. This factored this way. This one was missing an x plus 3. This one was missing an x minus 3. That would make this numerator x squared minus 3x. This one becomes x squared plus 2x minus 3. Then I do my side work. X squared plus x squared is 2x squared. Negative x minus 3. And then I factored it correctly. Nothing canceled out. That's my right answer. Huh. So usually you could expect stuff to cancel out, but I guess that's not always the case. By the way, right now you have enough information on the adding and subtracting rational expressions worksheet. You have enough information right now to do numbers 1 through 8, which is going to be Wednesday night's homework. So at this point, if you want to go ahead and stop and start with the worksheet, that would be a good idea. Do numbers 1 through 8, then go back and watch examples 3 and 4, and then that'll give you enough information to do numbers 9 through 15. And by the way, this is what numbers 3 and 4 look like. Let's do numbers 3 and 4. Number 3. Ooh, now we're getting to some subtraction problems. This one has an x plus 5. This one has an x minus 4. So they're kind of missing. Each denominator is missing the other one. So because this denominator is x plus 5, I'm going to multiply this fraction by x plus 5 over x plus 5. Because this denominator is x minus 4, I'm going to multiply this one, this fraction by x minus 4 over x minus 4. That will make the denominator x minus 4 and x plus 5. And you want to leave it just like this because there's a decent chance something might cancel out later on. The numerator, 3x times x minus 4 is 3x squared minus 12x. And then I have this minus here. Be careful. If people are going to make a mistake with these problems, a silly mistake, it's going to happen here with the minus. Because anything that comes after the minus is part of this other fraction, so it all needs to be in parentheses. 2 times x is 2x, and 2 times 5 is 10. So notice I put it all in parentheses. Now, let's do a little side work for that numerator. It becomes 3x squared minus 12x. If you distribute the negative, then it becomes minus 2x minus 10. Adding up your like terms, you get 3x squared minus 14x minus 10. Then you try to factor that. I'm not sure this one's factorable. I'm going to try a little Elliott factoring here for this one. Multiplies to negative 30, it adds up to 14. Negative 1 and 30, negative 2 and 15, that adds up to 13. Negative 3 and 10. Yeah, there's no way this is going to add up to 14. So this is unfactorable, which means I'm just going to write out my answer like this. 3x squared minus 14x minus 10, which was completely unfactorable, so we leave it like that. The denominator x minus 4 and x plus 5. This isn't the best answer in the world because you have a numerator that's not factored and a denominator that is. Maybe it'd be better form to multiply this out, but I'm actually perfectly okay with that answer. I'm going to sleep all right. All right, last example of today. First thing I want to do is, this is a lot like example number 2, really. First thing I want to do is factor the two denominators and kind of see what the other fraction is missing. X squared minus 4, that's x plus 2 and x minus 2. X squared plus x minus 6, that is x plus 3 and x minus 2. Alright, so now, when I look at this fraction here, this denominator has the x minus 2 that this one has, but it's missing the x plus 3. So I'm going to multiply this by x plus 3 over x plus 3. The second one, is missing the x plus 2. So I'm going to multiply by x plus 2 over x plus 2. Alright, new denominator. X plus 3. Boop. X plus 3, x plus 2, and x minus 2. Like I said a minute ago, order does not matter. Up here, 2 times x plus 3 is 2x plus 6. Minus, be really careful here. I like to put the second one all in parentheses so that this negative doesn't mess it all up. X times x plus 2, it becomes x squared plus 2x. Side work. I like dealing with the denominator kind of on the side simply because the denominator is already all set up ready to go. This becomes 2x plus 6. If you distribute the negative, it becomes negative x squared minus 2x, which becomes negative x squared. The 2x's cancel out, plus 6. And this doesn't factor. So I'm going to leave it like this. Negative x squared plus 6 all over x plus 3 times x plus 2 times x minus 2. And the hope would be that this numerator would factor out and then something would cancel out, but nothing did, so there's nothing else to do with this problem. Anyway, at this point, these two examples are hopefully enough to get you through the second half of the worksheet, numbers 9 through 15. We're going to spend both Wednesday and Thursday class working on these adding and subtracting rational expressions. So a good time to get caught up and get a little ahead. So I hope you're having a great day, and I hope you have a great night, and I'll talk to you later, everybody. Bye-bye.